So here's one more visual way of thinking about what we're doing when I take objects like polynomials, which don't seem like vectors, and use a basis to express them as their coordinate vectors. What does that actually look like? What are we doing? So if I take polynomials of degree at most 2, they form this vector space that we call P2. And I can take any one of those quadratic or less polynomials and express it in terms of a chosen basis. Let's say I choose what looks like a standard basis for this space of polynomials. And their coefficients we can package into a vector in three-dimensional space. And that coordinate vector then corresponds to our polynomial. So what's really going on here visually? Well, instead of thinking of this coordinate vector as being a point inside of three-dimensional space with x, y, and z components to it, instead, why don't we think about it as being a point in a three-dimensional space with x squared, x, and 1 coordinates associated with it. In other words, all of my polynomial functions are just vectors in a three-dimensional space where my axes are the x squared axis and the x-axis and the constant axis, if you like. And so every one of these different vectors that I'm choosing here, a different coordinate vector, is going to give me a different polynomial that came from the original space. So visually, this is what mental picture is in my head when I think about a polynomial as a vector. That really, it just means that I'm labeling the axes in my n-dimensional space differently. I'm labeling them with the basis functions that I have used to determine the coordinate vectors for my polynomials.